Let's start. Right. So we go back and we say that energy, we have done a lot of discussion. In this chapter, we will be talking about something called the total mechanical energy. Okay. The total mechanical energy. And the questions you will be getting will be very simple. They will ask you about a device and ask you what type of energy is being converted to what. For example, a solar cell converts solar energy to electrical energy. A motor, what is happening? Electric energy is being converted to mechanical energy. Since we are studying mechanics, we are interested on mechanical energy, and this energy can be classified broadly into two different types, which we have already studied. One being known as the potential energy. Okay. Sanvi madam, just have a look at the graphic size. If you feel them not satisfactory, do not hesitate to tell me up. And the other one being kinetic energy. Okay, these are the two energies which you will be learning till grade 11, 12. Potential energy always being represented as P, kinetic energy represented as Ke. Whenever you hear about potential energy, the thing that should come in our mind is that this is the energy possessed by a body by virtue of its position. पोजीशन, किसी पोजीशन के लिए ऐसा कोई पोजीशन आपको क्रिएट कर दिया दैट ड्यू टू दैट पोजीशन यू हैव एनर्जी. कहते हैं ना, जैसे एलओसी मूवी में जैसे फर्स्ट टाइम व्हेन द इंडियन आर्मी फेसेस लॉट ऑफ कैजुअलिटीज इन कारगिल, जैसे सर दुश्मन का स्नाइपर ऐसे पोजीशन पे है, हमारी आंख में एम ले रहा है, मतलब पोजीशन अच्छा है उसको. अगर पोजीशन के लिए आप में एनर्जी आ गया, दैट एनर्जी इज नोन एज पोटेंशियल एनर्जी. ठीक है. एंड इफ यू गेट एनर्जी बाय वर्च्यू ऑफ मोशन, अगर आप में मोशन आ गया, देन वी कॉल इट काइनेटिक एनर्जी. इस चीज को हायर क्लासेस में, ऑल्दो यू विल बी स्टडीइंग एवरीथिंग एज पोटेंशियल एनर्जी इन ग्रेड 9, बट यू शुड अंडरस्टैंड कि ये पोजीशन दो तरह से हम देख सकते हैं. वन इज अ पोजीशन व्हिच कैन बी अ पोजीशन एट्रीब्यूटेड टू हाइट, एंड व्हेनेवर यू हैव हाइट you have the effect of gravity on you. कोई चीज ऊपर से नीचे गिरेगा, तो ऐसे पोटेंशियल एनर्जी को हम कहते हैं GPE, gravitational potential energy, where G stands for the word gravitational. And there's an electric, it can be due to a constraint, है ना. आपको ऐसा एक कर दिया कि you have been constrained आ गया. That's something like a rubber band which was in normal texture, you stretched it, so you have constrained the rubber band. Hi Vivan, how are you doing now? Better? Yeah, you have some energy because I see you posting some stories, which means some energy has come back to your life. Have lot of musambi, beta. Musambi juice pio, and if possible, eat the musambi. Chew it, throw the debris. That way, your gums and your vitamin C is the only thing that we like when we are ill. Okay. So stretch rubber band. If you stretch the rubber band, you have constrained it. Release the rubber band. The rubber band can do some work. There is a spring, you press the spring, you have constrained the spring. Now the spring pushes you back, it can do work. Or the toys that I told you, if you wind the toys, you have coiled the spring wants to uncoil. So that sort of gravitational energy is called EPE, elastic potential energy, E standing for elastic. However, in grade 9, we are all worried about potential energy, and the type of potential energy that you are studying is basically gravitational potential energy, but we will not use the word GPE, we will be referring it more with PE itself. Is this clear or not? Okay? So when you say PE in class 9, you are referring to gravitational potential energy. Okay? Now by virtue of, what is it? It is due to, by virtue of what we call height. So चलो थोड़ा सा height के लिए देखते हैं. Let's say अमूल्य डार्लिंग समझ में आ रहा है तो बहुत अच्छी बात है. Let's say this is a ground level, and at this ground level, suppose I have a body, and this body carries a mass m in it, right? This body carries a mass m in it. Does this body have any energy with it? No. Any potential energy with it? No, because the body does not have any height right now. Potential energy can be with respect to position, and that is at height. Now what I do, I start lifting this body, and say suppose the body has been lifted to this position. ये m है, और यहाँ से यहाँ तक की जो दूरी है ना बच्चा, that दूरी is h. Now we have put it up at a height h. Does this body have potential energy? Yes. We say yes, it has potential energy. Now at, let's say this is position 1 and this is position 2. So we say at 2, 2 बोलता हूँ, u लिखता हूँ. See how much the brains have got damaged these days. Okay, at 2, the PE is equal to 0 because the height is equal to 0. The body does not have any height. Now at 1, body has PE, and we will now calculate what is that value of PE. You know, some writing disorders of children, that these are diseases which you find. Like when you ask a child to write R, you'll find he's writing ulta R likhta hai, ठीक है? Like Russian R जैसा लिखता है. These are disease, you know, some types of disease. ठीक है? The body has potential energy. Now we all, our interest is to find out what is the potential energy of this body. So before we calculate the potential energy of this body, let us have a quick recap in terms of energy. And I told you that energy can be thought same as work, है ना? एक बॉडी में कितना एनर्जी है, जितना उसमें हम वर्क करेंगे, the amount of work that you do on a body is the energy. Because work, ऐसे सोचो ना, आदित्य is a body. इस पे वर्क करने के लिए हमको एनर्जी स्पेंड करना होगा. हमारा एनर्जी वर्क में तब्दील हुआ, चेंज हुआ, वो वर्क इसके बॉडी में घुसा, वापस एनर्जी हुआ. सो अगर बीच के वर्क को घुसा दो तो हमारा एनर्जी इसके बॉडी में गया. दैट इज व्हाट इज द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. एनर्जी कैन नाइदर बी क्रिएटेड नॉट बी डिस्ट्रॉयड, neither only can be converted from one form to another. I spent some energy, did some work, that work was done on him, so he gained that energy. ठीक है? तो यहां से अगर हम आगे देखें, energy same as work. So in order to find out the energy, देखो, in order to find out the energy at position 2, we need to find work done to move the body to position 2 from 1. Sanvi madam, have you understood this? ये वाला पार्ट समझ में आया? Did you understand this? I want to find out what is the energy at position 2. In order to find out the energy at position 2, I need to find out what is the work done to move the body from at position 1. Sorry, हाँ, गड़बड़ा गया है. What is to find out? In order to find out the position 1, we need to find out work done to move the body from 2 to 1. Okay, 2 to 1. कितना वर्क करोगे वही तो एनर्जी बन के रह जाएगा. इज दैट क्लियर? हाँ, शेर श्रीवास्तव, यौन करते रहो. मेरे क्लास में यौन खूब यौन करो, ठीक है? Right? Okay. So now our quest is to find out work done to move body from 2 to 1. Oh darling, look at the handwriting, how nice he writes, one straight line. Work done to move from 2 to 1. And work done is what? Work done is always force multiplied by displacement. Okay, so our job is now to find out what is the force needed and what is the displacement. So let's have a quick look. If you consider the body with mass m, the body is actually has its weight which is equal to mg. Mg is equal to w, and w is a force. So in order to lift this body, don't you think that you should be giving a force which is at least equal to w? Yes, so you should be giving a force. So let's give that force. So let's say this is our force with which we will be pulling up this body. So this is the force, and this pulling up force should be F, and this F is nothing but W, that's nothing but mg. Do you agree? Yeah. And is the height not the displacement? This much you have to move it. The height is the displacement. इतना ही तो ऊपर उठा के ले जाना है. And what is the, so if I draw a diagram here and I tell you that my force is directed, अरे बाबा टाइट हो जाना, my force is directed upwards, my displacement is also directed upwards, right? my force is directed upwards, my displacement is also directed upwards. So can you tell me what is the angle between them? The angle is 0. Any vector can be slided over any other vector. Angle is 0, right? So my work done now transforms to mg multiplied by h into cos of 0 degree, and we know cos 0 is equal to 1, right? Therefore, the work done is equal to MAGH, mgh. Got it? If work done is mgh, then finally energy is work, work is energy. So we say the energy at position 1, and let us add an adjective to this energy, the adjective being potential energy, because it is with respect to position. Potential energy at 1 is given by mgh. So this part is actually your force, this part is displacement, which actually satisfies the clause of energy. So mgh is. Now you put yourself, what is the energy at 2? Look, at 2 h is equal to 0. So mg into 0, 0. Now two more questions to you. I have a body here, I have a body here. Which body has more energy? The body which is at higher height, because its h is more. Or if you don't understand the simple thing, put your head below here and think 2 stones, which is going to damage your head more. That has more energy. Simple ना? ऊपर से पत्थर मारेंगे, बीच से मारेंगे, किसमें सर फटेगा? ऊपर से पत्थर, बस खत्म. लिख लीजिए, समझ में आया तो, and then we will do some rubby on these. Yeah, Vivan, what is the YouTube channel you are watching right now? Okay. You got a reply from the friend you sent the Discord chat right now. Did you get the reply?
I don't use Discord.
Okay. Anytime you post something on Skype, this fellow is the first one. Immediately he was. When mobile is always in hand. So potential energy is given by the formula mgh. Okay. Now how they will trick you in these problems? They'll trick you like this. Look at the trick. So the tricking will happen in this manner. These are the steps that Mr. Jones has to climb up from here. Mr. Jones climbs these steps to reach a position B from position A. Okay, and Mr. Jones is right now something like, say, then there's the wall. Mr. Jones is some A distance from the wall, and Mr. Jones needs to climb up to position B, right? And he climbs the stairs. Huh? No? Oh, no hands? Okay, we'll make some hands also. Okay. Will we समझ ले, Mr. Jones? You want some eyes also? We can make some eyes. Okay. And he has had his breakfast, potty करके आया है, ठीक है? और बाकी. So Mr. Jones is now trying to climb up to position B from position A, and in book what they will do, they will trick you. How they will trick you? They will say that this particular height of each stair is y, each stair, and the width of each stair is x. They'll say it like this. The width of each stair is x. And Mr. Jones has a mass of m. Find the potential energy that will be there with Mr. Jones when Mr. Jones reaches the top. So here Mr. Jones is energized. And they ask you, find out what is the potential energy here when he has reached here. How many children think that potential energy is what? Mass into gravity into height. How Mr. Jones goes from here to here is nothing of our, nothing. All we are interested is how much is the displacement. Again, go by chapter 1. This is initial position, this is final position. So the displacement is always this height. So either you add up all the y's, the x were given to you just to confuse you, or they may tell you that the diagonal measurement of the stairs is blah 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 blah. Even if that is given to you, use Pythagoras theorem and find out this. This is what is important for us. वो कैसे गया? Steep सीढ़ी से गया, 14 सीरीज से गया, हमें कोई मतलब नहीं वो कितना हाइट एक्चुअली उठा, वही उसका पोटेंशियल एनर्जी है. बिकॉज in the definition of work, this is displacement. Displacement is the shortest straight line distance from initial to final. तो आप बोलोगे shortest straight line तो ये है hypotenuse. नहीं, हम सिर्फ हाइट को देखते हैं, यहाँ पे h को देखेंगे. Along the direction of the force he is lifting himself. तो ये वाले प्रॉब्लम्स आने से याद रखिएगा, what is important to us is only the height. And how they have given you, basically they'll give you some application of Pythagoras theorem. You just concentrate यहाँ से यहाँ कितना ऊपर उठा. So the best way to judge these problems are, you always find out what is the height here and you always find out what is the height here. ये is what is the thing that we are interested in. Do we understand? Any questions on potential energy? We'll do some problems. CBSE में तो चिन्नू question आएगा. चलो एक question कर ही लो. Now let's do a question on potential energy. Let's do a question on potential energy. Okay, children. Okay.
We're recording.
Yeah, we are recording. Not yet halfway.
No.
Yeah, I have to be reminded. So, acceleration due to gravity is 10 meter per second square. So, right, G is equal to 10 meter per second square. The question says G is equal to 10 meter per second square. The mass is 1 kg. M is equal to 1 kg, right? And the height is equal to 5 meters. So, dear children of CBSE, calculate the potential energy. Still wrong, 50 joules. ठीक है. अब क्या करें यहाँ पे, ऐसा अभी करेंगे ना, बहुत टाइम है. HC वर्मा पूरा बुक करना है हमें, ये सब खत्म हो जाए उसके बाद. Okay, the next question. We have a bag whose mass is 200 kg, a bag of wheat. So just take it as bag. The mass of the bag is 200 kg. I want it to have a potential energy of 9800 joules. The P should be 9800 joules.
So what is mass? 200.
200 kg. I usually don't repeat my questions. Mass is 200 kg. I want the body to gain a potential energy of how much? 9800 joules. So this is a clear indication that G should be 9.8. Very good. I like that. G should be taken as 9.8. And tell me, to what height should I raise this body? Right? Like I am a body right now. I want in my body to come how much? 98 joules. तो मेरे को थोड़ा ऊपर उठाना पड़ेगा. कितना ऊपर उठाना पड़ेगा? Do. Mass into gravity into height is potential energy. यही नहीं कर पा रहे और हंसते हो. P is given, M is given, G is given. You have to find out H, or else the window is open. Where did I keep my duster?
5 meters height.
Oh, great! I will recommend you for the next Nobel Prize. Understood? Can I rub these, children? Okay, good. Five meters. So if you raise it to a height of 5 meters, it attains an energy of how much? 9800 joules. Well, now move our focus to the next form of energy known as kinetic energy. And kinetic energy is always attributed to a body in motion. A body in motion. So the motion word makes a sense. See, I was telling you, right, how to use mind map and study. If you ask me how I study like this. Say suppose I'm reading a book right now. Kinetic energy is attributed, I'm reading the book in English but I'm making my notes. Kinetic energy is attributed to a body in motion. A body in motion means the body must have a velocity v. right? The velocity v. These are keywords. There has to be a velocity v. So I would also say if the body is at rest, then I write my ke should be equal to 0. Whatever the book wrote in one paragraph, I have written it in symbolic language. That's how you have to learn. That's how you should study biology, social studies, and other subjects. Imagine like my student who's there in US, she studies AP Physics, AP Maths. They've got history also. She has got history as a subject, apart from in her grade 11, and she would be joining us on Wednesday's class. I have asked her to join us. Asked her to y'all for a Q&A session of you guys with her. She is a girl who, okay, that I'll not share now because it will be very beneficial. She's in grade 11 right now in US. ठीक है, और आपको मजा आएगा उससे बात करने. I have made her it will be morning 9 o'clock her time this Wednesday, so she will join our class on Wednesday. It will be Q&A session. We will have a talk with her. She wants to join that class. ठीक है. Now she's been with me from same like grade 9. So K is a body in motion, and okay, so K for body in motion, you should have velocity, and at rest Ke will be equal to 0. So all we are now interested is to find the expression for Ke. Expression for Ke. We will try to find out what is this. Like just you had an expression of mgh was the expression for what? Potential energy. We will now find out what is the expression for a kinetic energy. ठीक है? Now, in order to find the expression for kinetic energy, we have to think of a scenario. Just try and think. Okay, let's try and imagine. Okay. Suppose we have a body of mass m. There is a body of mass m, and this body of mass m is moving with a uniform velocity of v, right? This is moving in uniform velocity of v, and in some medium, let's say this medium is air. Let's say this medium is air. It's moving with a uniform velocity. So now uniform velocity means no acceleration is working on the body, no net retardative force or anything. Have you understood? If this body is moving with uniform velocity in this medium of air, can I say that this body has kinetic energy in it because it is in motion? The body is in motion, it is moving with a uniform velocity v. Understood? So if it is moving with uniform velocity v here, the body must also be in uniform velocity with v right here. Right? Here also it is with v. At this place, this is the interface between two mediums. Let's say from air, this body has suddenly a high jumper hai. From air, it is now moving inside sand. Ab sand ke andar ghus raha hai ya pani mein ghus raha hai. So let's call this as medium 2. I call this as medium 2. Yeah? Understood? There is some other medium now. So the body is moving in one medium. In that medium, it does not have any sort of, what do you call, acceleration, uniform velocity, and that body has been made to move in another medium. Just because it has come in another medium, this body faces retardation. ठीक है ना? This body faces retardation, and let's say by the time the body reaches this position, the velocity of the body becomes equals to 0. The mass still remains m. The body traveled from this place to say this place, the distance that it has traveled, let's say the distance traveled is s. Have you understood the scenario? The body has traveled a distance s, and here it has faced retardation. Retardation, that is negative acceleration, that is force against its direction of motion acted on it. Force against the direction of motion. That means as the body entered this medium, there was a force which acted in this direction, and there was an acceleration also which acted in this direction, right? And they caused the retardation. Is this thing understood? है ना, दलदल में घुस गया है, कुछ तो फोर्स अटैक कर गया इस बॉडी को, बॉडी रेस्ट पे आ गया, एंड द बॉडी हैज मूव टिल दिस मच, राइट? नाउ जस्ट इमेजिन, if the body has velocity 0, then can I write that the ke at this position should be equal to 0? ये आता है, लेकिन हाँ, derive the expression for kinetic energy. The ke at this position should be 0. That means from, if I call this as position, let's say I call this as position 1 and I call this one as position 2, right? From 1 to 2, body lost all its ke. It had a ke here और यहाँ पे 0 हो गया. That means body has lost all its ke. But we know energy can never be created nor be destroyed. Yes. Where did this body energy go? Why did you lose the energy? Why did I lose energy? See, if there was no force acting against me, I would have been happily going. There is no energy loss. Just because there is a force against me, I am now struggling to go. So I am putting some effort. And I am putting some effort means I am doing some work against that force. Do you get it? So whatever work this force has done, that work was actually countered by me to lose my energy. समझ में आ रहा है कि नहीं? Just imagine, I am having some kinetic energy out here. My kinetic energy became 0 at this position. Where did the kinetic energy go? I must have lost it to some activity. What was the activity? The activity was to fight against this force. That means the force did work on me. This force will do some work on me. This force is doing negative work on me, and negative work means depleting my energy. I'm going against this force. I'm losing my energy. So can I say that if I can find out what is the work done against this force, that is the energy lost by me? That should have been my kinetic energy right at the start. So I can say the loss in ke is equal to the work done against the opposing force. The work done against the opposing force, whatever was the work done against the opposing force, that is actually my loss in kinetic energy. है ना? वर्क करने के लिए एनर्जी तो चाहिए, कहां से आएगा? अपना काइनेटिक एनर्जी खो दिया, उसी से मैंने वो वर्क किया, और वर्क करते करते एक जगह जाके रुक गया. अब इस वर्क को कैलकुलेट करते हैं. चलो, कैलकुलेट दिस वर्क. नाउ वर्क done should be equal to force into displacement. Understood? Force into displacement can be written as, force is what? Force into displacement. The force is again equal to mass into acceleration of the body into the displacement. Do you agree? Our job should be now to find out what is this particular acceleration. Alright, let's try to find out what is this acceleration. What do? I do it here. Let me use this equation of motion where v square is equal to u square plus 2as. Now mind you, my v is 0. My v is 0 and my u is v in this case. Did you understand this thing? My u is 0, my v is 0 and my u is v. What is u? Initial velocity. My initial velocity is v here. I have taken the expression as v. So can I write 0 square is equal to u square, that is v square plus 2as. I can write that. Can I bring the expression of a from here? Let's try and bring the expression of a from here. What will be A?
is B minus.
Now we are doing work. Okay, now work. Now we need to take care of our signs. We have not taken care of our signs. Just take care of our signs first. नहीं तो हमें लफड़ा हो जाएगा. Okay, let's take care of our signs because your distance, your acceleration is negative in this case. So this is negative A because you are doing acceleration इस side में है, उल्टा acceleration है, right? So v square can be said as 2as. Agreed? So A can be written as what, बच्चा? V square divided by 2s. Do you agree? ठीक है? Now bring this value of acceleration and punch it here. So the work done becomes m into v square divided by 2s into s. S cancels s and the work done is given by half mv square. ठीक है? Now you may say, sir, why didn't we take the f as negative? We actually took the f as negative. Why? Because you calculated this a, you made the a negative. Ultimately f negative होके आया है. ठीक है ना? So work done कितना आया? Half mv square. So if the work done is half mv square, then we will say the kinetic energy lost is also should be equal to half mv square. And this gives you the formula for kinetic energy of a body. Man, that means the kinetic energy of the body at this instant, just before it entered, the kinetic energy was how much? Half mv square. And here the kinetic energy became 0. So how much kinetic energy did you lose? Half mv square I lost. How much work did you do? Half mv square work you do. So kinetic energy's formula is equal to half mv square. Now you get one very nice expression from here, that if a body's velocity is more, its kinetic energy is very more, because kinetic energy is dependent on square of velocity, not velocity square. That's why when a bullet is fired with a huge velocity, the kinetic energy और डबल नहीं स्क्वायर हो जाता है, इसलिए वो आर पार करके चला जाता है, उसकी kinetic energy बहुत ज्यादा है. और जिसका और एक और रास्ता हो सकता है that you make the mass more. Example is an elephant. धीरे धीरे चलता है, लेकिन जिसको धक्का मारता है धम मार जाएगा, गिर जाएगा वो भी. मास ज्यादा है उसको. बुलेट का मास कम है. अगेन गोइंग बैक टू मोमेंटम वाला कॉन्सेप्ट ही है. If you have more, a body which has more momentum has more kinetic energy. Simple. Because the momentum can be more either by mass or by velocity. The kinetic energy can be more either by mass or by velocity. So two expressions we have got, children, that potential energy यह भूल नहीं सकते हैं up till grade 12 is mgh. Kinetic energy is half mv square. Half mv square. In some books, they will also derive Ke in terms of momentum. We can do that also. Let's do that also. Let's see. ये हो गया. यहाँ से थोड़ा सा मिटाएं अभी. Okay. So a total mechanical energy at is always given as, that we will study now, sum of potential energy and kinetic energy. तो यहाँ से हमें दो चीजें मिली. हमने kinetic energy भी सीख लिया, हमने potential energy भी सीख लिया. अब एक मजेदार चीज सीखेंगे आज. Okay, so what is the value of kinetic energy? Just see, half mv square, right? You also know that mv is equal to momentum, isn't it not? Right? mv को हम momentum कर सकते हैं, यानी कि v की वैल्यू क्या हो जाती है? p over m. ठीक है, तो इसको थोड़ा और सुंदर से लिखते हैं. Kinetic energy is equal to half mv into v लिख सकते हैं, हाफ p लिख सकते हैं mv की जगह पे, और v की जगह पे p by m लिख सकते हैं, है ना? नहीं, ये फॉर्मूला रहता है, ये सीबीएसई कवर नहीं करता है, बट दिस इज. सो इसमें क्या आ गया? 2ke is equal to p square by m, right? 2ke is equal to p square by m. So momentum can also be found as 2mke का रूट. ये 11 में ये फॉर्मूला सिखाते हैं, एक ही चीज है, 2mke.
M into V is better.
M into V is better, no, that is understood, but when you will go for collisions of atoms and molecules, this formula comes up, 2mke. बच्चे क्या कंफ्यूज कर जाते हैं पता है, ये mv को mv की जगह में p लिखने का ना, और v को अलग से लिखने का, राइट? अब चलो इंटरेस्टिंग चीज देखते हैं, इतना समझ में आया कि नहीं? सो ऑल एट ग्रेड 9 यू नीड टू रिमेंबर इज ग्रेविटेशनल एनर्जी इज p is equal to mgh, kinetic energy is equal to half mv square, half mv square. ठीक है? Can I rub the right hand side, kiddos? Can I rub the right hand side now? Now we'll see some interesting things that happen. Okay, chalo. Okay. अब और इंटरेस्टिंग चीज देखते हैं. So let's do one more scenario out here. Okay, now what we do is ये देखो, this will make you understand why energy is constant. So let's take a tower of our my home jewel. Why always Pebble City? Where is the my home jewel girl? She's there. So what was the tower? Well, my home jewel towers are like in the name of what? Hey, what was your tower name? I'm forgetting. Topaz? No. Amethyst. Amethyst. Yeah, amethyst. So we are at Amethyst Tower, and by now you know two things. The PE is given by the formula MGH. The KE is given by the formula half mv squared. Okay. So what we do? We take a ball, not here. So Sudhriti takes us to Amethyst Tower right on the top, and let's put a ball here at this level. Okay, let's put a ball at this level, and let's say that the height of Amethyst Tower is how much? H. The height of this tower is h. Okay, h is the height of the tower, and the mass of the ball is m. The ball right now is at rest. This is scenario 1. Scenario 1, ball is at rest, mass is m. So we say position 1. देखो कितना मजेदार derivation आएगा यहाँ पे. Position 1. What is happening? Mass is equal to m, velocity is equal to 0, height is equal to h. ठीक है ना? And g is equal to g. ठीक है ना? G is equal to g. So once you see v is equal to 0, you will straight away say ke at the position 1 is equal to 0. No doubt about that.
Yeah.
Right? And from this data, if I ask you, beta, what is the P at 1? You will say it is MGH, mass into gravity into height. Clear? So if I tell you, can you tell me what is the total mechanical energy out here? At 1, you say it is equal to KE1 plus PE1, which is equal to MGH. Understood? The total energy in this body right now is MGH. But our Sudhriti is not an innocent child. She observes somebody going, "Hey, इसके सर पे बॉल मारते हैं, चलो चलो मारते हैं इसके सर पे, वाओ कितना मजा आएगा." So she drops the ball and say the ball has come somewhere at this level. कहीं भी आ गया है, आर्बिट्रेरी ले लो, ठीक है, बॉल यहाँ आ गया है. बॉल कितना ट्रेवल करके आ गया? हम कहते हैं बॉल ना ऊपर से x डिस्टेंस ट्रेवल करके आ गया, ऊपर से x डिस्टेंस नीचे ट्रेवल करके आ गया, इतना नीचे आ गया. अब हमारा बॉल यहाँ पे है, ठीक है, दिस इज आवर पोजीशन 2, ठीक है, ये पोजीशन 1 हो गया। अब पोजीशन 2 का एनालिसिस करते हैं, आ जाओ। वाओ, पोजीशन 2 में मास कितना आया, m है। अब हल्का थोड़ी हो गया होगा, बॉडी है, ऊपर से थोड़ी बॉडी मास कम हुआ होगा। अच्छा, हाइट कितना है अभी बॉडी का, h minus x. Height is, my dear, never measured from top, always from bottom to top. H minus x, not x. X is what it has descended. ठीक है, तो हाइट इज, तो यहाँ पे हाइट कितना है, अरे यार हमें तो ये कैलकुलेट करनी है ना ये हाइट, इसीलिए तो उसको ऐसे बनाया था, गड़बड़ी है, h माइनस एक्स, ठीक है ना, इतना हाइट पे है गाड़ी, ठीक है। और g कितना है भाई, g तो भगवान ने g दे के रखी है, तो इसका निकालते हैं, पहले p निकालते हैं, p at 2 will be m g h minus x mgh. This is the height. Have you understood or not? सानवी, शेर श्रीवास्तव बीच बीच में कैमरा बंद करता है, वो अलग बात है, हाँ, चैटिंग वैटिंग मारते रहता है बीच में। अरे वाह वाह वाह, वॉशरूम में कैमरा लेके गया था क्या? अच्छा अच्छा, काइनेटिक एनर्जी निकालते हैं यहाँ पे। काइनेटिक एनर्जी विल बी गिवन बाय हाफ m v at 2 का स्क्वायर, 2 पोजीशन पे जो वेलोसिटी होगा उसका स्क्वायर होगा, है ना। अभी तो इस ससुरा हमको पता नहीं है, इसको निकालते हैं। डोंट यू थिंक v at 2 square, you are coming downwards, you are coming downwards, so this velocity will be negative velocity, is equal to u square. U is also downwards, but in our case u is 0, initial velocity is 0, ठीक है, plus 2 into negative g. Why negative g, sir? Because we are coming downwards, we are coming downwards. And how much distance you came? Now negative x, because you just came negative x downwards. If you understood this thing or not? v square equal to, नहीं, ये समझने में आसान लगता है, पर साइंस समझ में आया। v square is negative v2 square is equal to u square is 0, initial velocity 0, 2 a is negative, always negative, into s is, नीचे जा रहे हो तुम, कितना नीचे आया, ये नहीं, ये नीचे आया, नेगेटिव x, तो इसको निकालते हैं। तो v2 का स्क्वायर क्या आएगा बेटा, v2 स्क्वायर ही आएगा, ये नेगेटिव तो पॉजिटिव ही हो जाएगा, और यहां से कितना हुआ, 2gx, समझ में आया। तो काइनेटिक एनर्जी कितना हो गया, हाफ इंटू m इंटू 2gx, 2 cancels 2, so it is major x. This is ke at 2, darlings, have you understood? Can you now calculate what is the total mechanical energy at 2? It will be the potential energy. Now split open the potential energy, mgh minus mgx, this is potential energy, पूरा split किया इसको, plus the kinetic energy, this is the potential energy plus the kinetic energy of mgx. Wow, this thing is cancelling this thing, that means the total energy now also is coming mgh. Just look at that, देखा मजेदार चीज, यहाँ पे कितना आया, यहाँ पे कितना आया, wow, that means body has neither gained energy not lost energy, but what has happened, it has lost its potential energy which was gained as kinetic energy. यहाँ पे kinetic क्या था, 0, अभी यहाँ पे क्या था, यहाँ पे हमको P था क्या, हमको यहाँ Ke था, नहीं, यहाँ पे हमको P है और Ke भी है, लेकिन अगर खूबसूरती से देखा जाए तो ससुरा P डाउन हुआ है, Ke अप हुआ है ना। अब नीचे ले आए बॉल को, मजेदार। हाँ, अब पोजीशन 3 में आते हैं भाई साहब, पोजीशन 3 में मास कितना होगा शौर्य, m, हाइट कितना होगा, अंडा, वेरी गुड, किसने h बोला था, ये पास से ज्यादा दिखता है क्या, पाताल में थोड़ी जा रहे हैं, यहीं पे तो है, हाइट 0 हो जाएगा, है ना। g कितना होगा, g होगा, तो यहाँ पे इसको हाइट 0 देखते ही तुम्हारे दिमाग में आना चाहिए कि p at 3 should be equal to 0। तो यहाँ पे हम क्या लिखते हैं, एक चीज लिख दें कि pe जो है यहाँ पे 0 हो गया, मतलब के कैसे जीरो होगा? एनर्जी अगर तो समझे ही नहीं, पोटेंशियल एनर्जी पूरा जीरो हो गया तो जाएगा कहां? वो के में ट्रांसफॉर्म होगा. दैट हैज टू ट्रांसफॉर्म टू के. Don't you think if I put your head right out here, it will be squashed the very nice way? The maximum velocity will be here, right? Dham se girega wo. So here we will find that Ke, here Ke is minimum, this is maximum. Here ulta will happen. This is minimum and this will become maximum. Let us prove that. So let's find out what is the Ke at 3 will be equal to half m and v at 3 ka square. Right up? So let's calculate what is V at 3. So negative of V at 3 square is equal to U square, that is the initial velocity, which is 0 square, plus 2 into negative G into what is the distance now traveled? Negative h. No, by x minus h. You're taking the entire distance traveled now. So it is, you've taken 0 now. Initial velocity is 0. So initial point is here. How much did you travel? Negative h you traveled. So what is V3 square coming up to? 2gh. 2gh. Input this value here. So you get the kinetic energy as half into ma into 2gh. Oh, 2 and 2 cancels. This is again mgh. Right? Therefore, the total mechanical energy at 3 is equal to PE at 3 plus KE at 3, which is equal to Laddu plus Magaha. So, which is equal to Magaha. Now, just look at the three expressions. The total mechanical energy at 1 is Magaha. The total mechanical energy at 2 is Magaha. The total at 3, which clearly shows us the conservation of energy. Energy is neither created nor destroyed. It is only converted from one form to another. Okay, the notorious children in Pebble are neither created nor destroyed. They are just converted from one. Few become senior students, they become good. They again make bad younger students. Younger students again become bad. They become good as they go out against few younger. So the number of students playing football at night always remains constant. It's just that the Shauryas transform and then leave football, get into some more interesting topics of life, and this can be you know babes, this, that, and then more younger ones start playing football. So the people who are residents at B Tower, they continue to face the same constant chaos. Energy remains the same. Somebody is every night playing football. It is only that the players are changing. So it's same like this. The total mechanical chaos always remains constant. Have you understood? Such a lovely expression. So what did we understand? We had maximum potential energy. We had no kinetic energy. As we started coming down, our kinetic energy starts to build up and our potential energy starts to go down, down and down. ठीक है? और इस पूरे चीज को अगर आप एक डायग्राम के जरिए देखना चाहें तो इसको आप एक डायग्राम के जरिए भी देख सकते हैं. देखो कितना इंटरेस्टिंग हो जाता है. ठीक है, इसको एक डायग्राम के जरिए देखते हैं. आइए, और डायग्राम कुछ ऐसा है. Now this is a double graph that I am trying to make. What I am trying to make? Double graph. Now this side I am measuring height and this side I am measuring energy. ठीक है, it's a double graph. Double graph मैंने अभी भी single graph है, इधर और एक axis डालूंगा अभी. ठीक है ना? This side is height. So let's say the height of Amethyst Tower in my home Jewel, the height of Amethyst Tower is this, 20 centimeters. ठीक है ना? Only reptiles live there. So this is the height of, we started from here. So let me call that this is my height tower and this was the height of Amethyst Tower, 80. Right? Now tell me, when my height was maximum, what was my kinetic energy? Zero. So shall I plot my kinetic energy? I am plotting with red color. I am plotting my Ke is equal to 0 at that time. Right? What happened to my potential energy when my height was there?
Highest.
My potential energy is highest. Okay. So my potential energy I will plot with green pen and I say that my potential energy is here. हाईएस्ट पोटेंशियल एनर्जी एट दिस पर्टिकुलर हाइट. कैसा करे, ऐसा दिखा दे दिस पोटेंशियल एनर्जी. ठीक है. नाउ एज माय हाइट started to reduce, what happened to my potential energy? My potential energy started to fall. So when I say a double axis graph, I am actually making my next axis out here. This is another axis, and this axis also shows my, and this, now please understand, this is one axis of the graph. Either you read it this way or you read it this way. In this way, this is also energy. Okay, and say my P was maximum, so I am putting my PE as max out here. Just look at the green curve now. Just look at the green curve versus this one. Okay, as my height starts to fall, what happens to my potential energy? It reduces. At the minimum height, the potential energy becomes equal to 0. So don't you think the potential energy starts taking a graph like this? Potential energy 0 आ जाता है. So I write here Ke equal to 0 at H is equal to HAT, which is max height. ठीक है. And P is equal to max at max height. At max height, the potential energy is maximum. ठीक है. Green curve is okay? Yes. Now let's look at our Ke graph. So how do we measure our Ke graph? Now there is a small thing. Rather than, since I put energy on this axis, let me now put the Ke also here. तो मजा आएगा. Because energy is being shown in this axis. इसको छोड़ दो अभी चाहे तो. इसको छोड़ दो. इसको छोड़ देते हैं. इसको energy दिखाते हैं, इसको height दिखाते हैं. तो यहाँ बोले Ke is equal to minimum. At this particular height, Ke is minimum, right? It will become maximum as you go up. Okay, Ke is minimum, and at height equal to maximum height. Why I am doing both the graphs? I could have done them separately also, Ke, Pe separately, but ऐसे करने से आपको मजा आएगा. अब जैसे जैसे हाइट नीचे आता है, Ke का वैल्यू क्या होता है? बढ़ना शुरू हो जाता है. तो Ke मेरा कैसा हो जाएगा? Ke will take a shape like this. So I'll tell you how to read the graph. If you are reading the graph in terms of Ke and height, then for Ke, we will say this side is energy. For the Ke graph, this side is energy, this is 0, and this is max energy, max. This is for the Ke graph, 0, maximum. Height comes down, this is maximum. And when we see for the P graph, we will see the P graph in this way. This is when the height is maximum, P is minimum, energy is this side. I have combined both the graphs, and here P becomes equal to 0. यहाँ पे P 0 होता है. अब आप देखो, किसी भी एक पर्टिकुलर पॉइंट पे टोटल एनर्जी कांस्टेंट होना पड़ेगा ना. किसी भी एक पॉइंट को ले लो, एनी वन पर्टिकुलर पॉइंट. ओके, इफ यू आर गेटिंग बोर्ड विद द ग्राफ, डोंट वरी. आई नो थोड़ा सा समझना मुश्किल होगा इस एज में. एट एनी पर्टिकुलर पॉइंट, लेट्स से एट एनी दिस पॉइंट, at this point, let us find out what is total energy. At this point, the total energy is always the area of this triangle, area of either of the triangle. So at this position X, you know how much of Ke do you have? I have this much of Ke. How much of Pe do you have? I have this much of Pe. Ultimately, it's the area of one triangle. दो ट्राइंगल को कंबाइन किया है. ऐसे अगर आप ऐसे देखो तो आपके लेवल में ड्राइंग ऐसा रहेगा. This is potential energy, this is height. When the height is maximum, the potential energy is maximum. When the height is 0, so potential energy climbs like this. This is kinetic energy, this is Ke, and this is height. When the height is minimum, the kinetic energy is maximum, and when it is maximum, it is minimum. इसको क्या किया? इसको ऐसे घुमा के इस साइड ले आया, तो दोनों ग्राफ ऐसे बन गए. ठीक है, मजा आया? आपको जो पूछेगा इस क्लास में, वन इज डिराइव द एक्सप्रेशन फॉर काइनेटिक एनर्जी, दैट यू विल गेट. वो आता है आपको. Second is, what is the law of conservation of energy? Total energy remains constant. It's only that one energy gets converted to the other. And one last thing, it will take just 30 seconds, not more than that. They may ask you, how does the kinetic energy change with velocity? That you can just see by the formula. Ke is equal to half mv square. So if you, let us double the velocity. Let us double the velocity. Ke dash. Ke dash becomes equal to half of m 2v square, the new kinetic energy, right? 2v square. So if you try to solve this, it is how much? Half m 4v square. Can I write it as half mv square multiplied by 4, which is equal to 4 times of original Ke? तो ये लिख लो. The kinetic energy increases 4 times if the velocity is doubled. If you double the velocity, the kinetic energy becomes 4 times. And let's make another one expression where we make half the velocity. Ke double dash is equal to half m v by 2 square. We are now making the velocity half. So how much is this? Half m v square by 4, which can be written as half m v square into 1 by 4, which is equal to 1/4 of original kinetic energy. So यहाँ आप एक statement लिख लीजिए, उसके बाद छुट्टी. If the velocity is doubled, the kinetic energy becomes 4 times the original kinetic energy. If the velocity is halved, the kinetic energy becomes 1/4 of the original, because you are going by a square law. If this square was not there, then इसको डबल करने से ये भी डबल होता है, लेकिन ये स्क्वायर पे है. तो समझ में आया? बंदूक की गोली को अगर डबल स्पीड से छोड़े तो उसका एनर्जी 4 टाइम्स हो जाता है. वो तुमको ही नहीं, 4 सुमो रेसलर को भी पार करके जाएगा. 4 गुना एनर्जी आता है. और बंदूक की गोली को अगर हम ढीला कर दें तो वो इतना कमजोर हो जाता है कि वो 1/4 एनर्जी हो जाता है उसमें. That's why a sprinter on the last lap, if you see the 5000 meter run where India got the gold, वहां पे भी अगर देखो, the Japanese and the Indian girl, the distance was इतना distance पीछे था. And if you watch the commentator, they say silver जरूर भारत को मिलेगा, silver is definitely confirmed. He little bit knew that at the last 800 this girl is going to sprint, and once she starts sprinting, वो जापानीज वाली लेकिन स्लो नहीं दौड़ रही है, वो अपनी स्पीड पे ही दौड़ रही है. इसका एनर्जी डबल नहीं, 4 टाइम्स होना शुरू हो गया. सो बाय द टाइम इट केम टू द लास्ट लैप, द इंडियन इज शी क्रॉस्ड. A huge moment of pride for India. We never used to get a medal. We are more than 100 medals this year. 107, yeah. And yesterday was all gold. Okay, so that's a great thing. So the thing is, ये question आपको पूछता है, हाँ, in what you call MCQs and all. If the velocity is doubled, the kinetic energy becomes 4 times. If the velocity is half, the kinetic energy reduces to, not reduces, it becomes 1/4 the original velocity. With this, we conclude energy. The last part is power, which we will be taking up in our last class. That's we'll do power tomorrow, and we'll complete this before our break. Right, okay, kiddos?